All right, we're going to talk about matrix multiplication, inverses, and not really determinants today. And then we're also going to talk about solving by inverses. Okay, this is going to make me googly eyed. We talked about matrix multiplication the other day. Okay, we're going to try one by hand here in a minute. But look, we have an amazing warm-up about Santa's elves. Okay. One of Santa's elves' buddy was making toy cars and dolls last night. Elves are actually paid to make toys, but you didn't know that. He's paid $1.50 for each car and $4.50 for each doll, and he made a total of $75 that night, last night, whatever. He produced 3 times as many dolls as cars. Okay, that's the sentence that's going to kill us. 3 times as many dolls as cars. Because think about this for just a second. If I say I'm 3 times as old as you, whose age gets multiplied by 3 if we want them to be equal? Okay, so we got to be real careful here. He produced 3 times as many dolls as cars. Which one did he make more of? More dolls. So do we want to multiply dolls by 3? No. Okay. All right, so I got to find a cursor that works. Okay, so define our variables. X equals, what do we have? Number of dolls and number of cars. Okay, now let's start with this one. He's made $1.50 per car, which would be Y, right? Because we did cars second. $4.50 for each doll, 4.5x. I'm going to put that in front so that when we put it in to our matrix, it's X and then Y. And that was $75. Okay. Then we have this weird sentence, 3 times as many dolls as cars. So dolls is more. So we're going to do 3 times the cars to get the dolls so that they're equal. Does that work for everybody? Mm-hmm. He produced 3 times as many dolls. So 3 times the number of cars gave him the number of dolls. We good? Okay, so that would be X equals 3Y. Or how can we set that up so that it'll fit in our matrix here? Okay. Now, this is not going to be a big matrix if we want to do what we did yesterday, which was, what's the command we learned yesterday? Anybody remember what button we went to? Reduced row echelon form, yes? Okay, yes. Okay, so what size is this going to be? 2 rows by 3 columns. So we are going to put in a 2 by 3, and I have a bunch of stuff already in here. This is not good. Okay, matrix, edit, over to edit, sorry. I'm going to put mine in 8 and 9 just to be difficult. So this is I only need 1 today, 2 by 3. We're going to learn another way that requires you put in 2 separate matrices. It's not my favorite because I don't like putting them in the first place. Okay, what am I putting in? 4.5, 1.5, and 75, was that it? And then 1, -3, and 0. Okay. Then we go back to quit and go back into matrix, over to math, up to RREF or choice B. And then we need to put the name of the matrix in. So if I go back here, mine was in number 8. I got 15 and 5, yes? Okay, so what is the sentence? Buddy made made 15 dolls, we put first, and 5 cars. Everybody good? Does work for just a simple little 2 by 2 even, okay? That's what we did yesterday. All right. I'm going to do number 2 first because I want to do number 2 by hand. What size are these? This is a 2 by 2, and this is a 2 by 3. Are we allowed to multiply those? We're supposed to do A times B, and then we're supposed to do B times A. Okay, A times B would be a 2 by 2 times a 2 by 3. These are the same, yes? So yes, we can do this one. And the answer will be a 2 by 3. But if I switch it around and put the 2 by 3 first, could we do that? No, this means not possible. Okay, for fun, we're going to try this one by hand in the order that it's written. Does anybody remember how this goes? We would get a 2 by 3. You would take this row by this column. Remember that? -1 times -2 would be 2, plus 3 times -3 would be -9. Then you stick with that row, but you move over to this column. -1 times 4 plus 3 times, was that a -1, guys? Okay, then you move over to this one. -1 times 0 is 0. Plus 3 times 2 would be 6. Then I'm going to go back and switch to this row and this column. -3 times -2 is 6. Plus 2 times -3 is -6. Then I have -3 times 4 plus 2 times -1. -3 times 0 plus 2 times 2. So I got as an answer for A times B, -7, -7, 6, 0, -14, 4. Did I add and multiply right, guys? Now, could we put that in our calculator and do it? We would have to enter A as a 2 by 2 and B as a 2 by 3, and then multiply them and hope we get this. Can you do that real quick for me on this problem? So matrix A is a 2 by 2 and matrix B is a 2 by 2, yes? Whoa. So I'm going to put them in my calculator. I might have already done that. Whoa, stop. Okay. Matrix A is a 2 by 2. Is this matrix A, guys? 2, 4, -3, -1? Is that right? Okay. If I quit and go back in to B, do I have B entered correctly as -1, 5, 0, -2? Okay. So now on my home screen, all I want to do is put the name of A times the name of B. And then I also want to do the name of B times the name of A. And notice I do not get the same thing, right? Everybody good? So I will put that on the notes, but I am not going to write it down. I think we got it. Not what you got? Did someone else get these? Did I do them right? Thinking you have something entered wrong in either A or B. But it's not. Okay, moving on, because this is not that big of a part of the lesson. All right, woo! This is on the post test, guys. Something like this, where you have a purpose for multiplying matrices. I think. Now I'm confusing myself. Anyway, maybe it is, maybe it's not. I'll remind you next week when we review for it. Okay, Holly, Joelle, and Louisa are competitive skaters. I know it's on the quiz. Friday. Their routines are judged on skating skill, choreography, and interpretation. So these are the three things they're judged on. Okay, and these are the three things they're judged on. Same place, same what they stand for. Okay, they received the following scores. Okay, Holly got 642, etc. One of two weighted systems shown below is used. So they could count skating skills 20%, choreography 50%, and interpretation 30%, or they could count skating skills as 40 and then split the other two 30-30. Okay, so what our goal is to figure out who does better under which system. Does that make sense? Okay, so what size is this little guy over here? This is a 3x3. Now tell me what the first three represents. The rows are the names, right? And the three is, what do they call them? What they're judged on? Criteria. Their criteria is this three, okay? This one is a 3x2, where this three is their criteria, and this 2 is the system A or B. Everybody see what I'm talking about? Because what has to be the same to be able to multiply them? This number, right? And it needs to be representing the same thing. So this is the same. Yes, we can multiply them. Our answer will be a 3x2, where the 3 will represent their names and the 2 will represent the system A or B. Is that making sense? Anybody lost? When you have row by column for matrix 1 and then you multiply it by row by column for matrix 2, these have to be equal and the answer you get will be this row by this column. We're good? Okay. So let's type these bad boys in. I think I have the first one in. So under matrix, which I just did wrong, I think I have mine in number 3. Or C, is that right? 642, 351, 246? Okay, but what do I have to put in for the other one? If I don't want ginormous numbers, guys.
Point.
Yeah, I need to put them in as decimals. So I'm going to go to matrix D. I have a 3x2, is that right? Okay. Can anybody read me the decimals? 0.2. 0.2.
0.4.
Across is 0.4?
Yep.
Okay.
0.5, 0.3.
Okay. Do I have it right? 0.2, 0.4, 0.5, 0.3, 0.3, 0.3. Okay. So now what do I want to do? Yes, I put those in C and D on mine. So I'm going to multiply the name of C times D, wherever you put them. Anybody else getting those numbers? Okay. Do I feel like I already have this on here somewhere? Oh, look at me. Hidden down here in the magic is the answer matrix. Okay. So, again, the answers matrix was Holly, Joelle, and Louisa system A and system B. Is everybody okay? So, use matrices to determine which system favors each skater. So what system favors Holly? Holly likes which one better? B. Joelle likes which one better? She likes A better, but she's still gonna lose, right? Okay, Louisa? Louisa's a, oh, why did I put J? That was supposed to be an A? A question mark doesn't really help her, right? But Louisa wins if it's system A. Holly wins if it's system B. Louisa wins if it's system A. Joelle, yeah, not so happy either way, right? Okay. All right, so what was the point of that? When to multiply, right? You have to know the sizes, and then you have to know what they stand for so that you can interpret the result. Everybody good? All right, matrix multiplication. It says identity matrix is any matrix that is a square with ones on the diagonal. So a 4x4 identity matrix would look like this. This diagonal needs to be ones, everything else is a 0. The identity matrix that is a square for a 3 would look like that. Does that seem okay to everybody? That is called the identity matrix, because if I multiply any matrix that is a 2x2 by this, it won't change it. It'll stay what it was, okay? It's the identity matrix. Now, an inverse matrix is what undoes something so that it becomes the identity matrix. That'll make more sense in a minute. So it wants to decide if these two are inverses of each other, okay? If you take A times B and it turns out to be, what would it be if it was an identity matrix, guys? If I did A times B, I would get what size? A 2x2 that would say 0, 0, 1. Okay? It says you should also do B times A and see if you get 1, 0, 0, 1. Okay? Because this is just a whole bunch of calculator garbage, I'm just going to show you. Can I just show you? Okay. It does say if a matrix has an inverse, then it is said to be invertible. A singular matrix does not have an inverse, so you will get a message sometimes that the inverse does not exist, or it will say singular matrix. Remember the whole idea that a system cannot be solved part of the time? All right, this is number 4. You have this one somewhere? The bottom of the page? Okay. So can you see what I did here? I put this in A, 11, 5, 2, 1. I put in B, 1, negative 5, negative 2, 11. Everybody good? Then I did A times B and I got this, and I did B times A and I got this. And so determine whether A and B are inverses. The answer is yes. A times B is equal to B times A, which is equal to the identity matrix, or 1, 0, 0, 1. Is that a good enough explanation? So if you had a homework question, it says, are these inverses? You could multiply them and see if you get the identity matrix, okay? I don't know if I even assigned one of those, but it's just a basic calculator typing question. Okay, this is number 5. I put in matrix A as 3, 2, 4, 1, matrix B as 1, 5, 4, 3. I did A times B and B times A. Are these inverses? Did this give the same thing? Did it give an identity? No, not inverses. Mostly just because A times B does not equal B times A, and neither one of them give the identity matrix. Ooh. No. It won't work that way anyway. Any questions? All right, there is a way to find an inverse on your calculator, so you could just put in A and then find the inverse and see if it's equal to B. That is this button right here on your calculator, which is the matrix button, okay? So, do I have a matrix in? Let's go with, I have a matrix A that is a 2 by 2, ready? Then you would push that same button to the -1 and it would give you the inverse of A. So now if I did matrix A times the inverse of A, I hope that order doesn't matter. I'm kind of confusing myself here. It's never good to do something you don't know what the answer is going to be. Yeah, if I did A times its inverse, it would become the identity matrix. Yes? Okay. So, and there's a way to do it with a 2 by 2 that you don't need a calculator, but I'm promising not to take your calculator away for this, so we're good. All right. This is really important, and it's very complicated to look at on this screen, but I am going to ask you to write a system of equations as a matrix multiplication problem. And that looks really confusing right there, so we're going to go on and talk about it here. Look what happens right here. If I take this matrix, and rather, remember yesterday when we did RREF, we would put this in a 2 by 3? For RREF, we put it in a 2 by 3 that looked like 2, -3, -1, and -3, 5, 3, and those are really scrunched together, I'm sorry. Okay, remember we did that yesterday? But this says if you are to write it as a, it says use an inverse, or it will say write as a matrix multiplication. Does this make any sense to anybody? What is this called? Do you remember? This is called the coefficient matrix. Okay. This is the variables x and y, and this is the answer. Let me explain why this makes a little bit of sense. Do you remember you do row times column to get this entry? Look at that. 2x minus 3y equals -1. Is that what we had up here? Then you would have this row times this column to get this entry. So -3x plus 5y equals 3. So kind of see how it works? All right, then what you're going to do after you have entered this in A, this is A, this matrix that's 2 by 2, this in B. Now, think about this for a second. When we had this equation, 6x equals 12, we divided both sides by 6, yes? You can't divide matrices. Could we have said instead, let me undo. Could I have multiplied 1/6 then to each side? And I would have got x equals 2, right? So that's kind of what we're doing. We're multiplying by the inverse. So what you do is you take the inverse of A times matrix B, and it undoes it and finds your XY matrix. But the order is important. It has to be the inverse of A times B. So I put this in matrix A, this in matrix B, and then I typed this on the screen, inverse of A times B, and it gave me this, 4, 3. So that means X is 4 and Y is 3. Now you ask, why would you do this? I like RREF better. I totally agree. Okay, but it wants you to know how to at least set up the question so that you could solve it this way. All right, this is another one done for you with the screenshot here. I think it's different numbers. This is a different example, isn't it? Okay, says you take the coefficients out here, 3, -7, -1, 2. Do you have this one? Okay. And then you have the XY matrix, and then you have -16, 8. Then on my home screen, do you see what I did here? A, then I did that little -1 button times B, and I got this. What does that mean the system solution is? What is X, guys? And Y, this is the XY that we found. So Y is -8. All right, we're gonna try one since everybody's like, what? Okay, ready? Do you have this one? Okay. Did they already separate it all for you? Okay, does everyone see where they got those numbers? -2, 1, 1, 1, 2. No, 1, 0, 2, right? 1, -2, -9. And then they have this XYZ, which is our answer that we're looking for. And then the answer is 0, 9, and -31. Okay, how fast can you type those in? What size is the first one? Oh, I'd be really happy if I had these, but I don't think I do. It is a 3 by 3. Okay, so I'm on number 5. Nope, just kidding. I want to edit number 5. All right, -2, 1, 1, 1, 0, 2, 1, -2, and -9. Did I get that one in right? Can anybody tell? I think that one's in right. Okay. I'm gonna quit, go back into matrix. I gotta go to another one. What size is the second one? 3 by 1, 3 by 1, okay, and 0, 9, -31. Okay, anybody remember how we put this on this home screen now? Yet A, so mine is actually not in A, I think it's in E. And then you do to the -1, so you just go back and hit the matrix key without doing second first. And then it's times, and you really don't need the times. It'll understand if you don't put it there that you want to multiply. And then you go back into matrix and put the name of the other one you did. Okay, what'd you get? Woo, how'd I do? We good? 1, -2, 4. So our answer matrix, I'm just going to write this down so you remember what we looked like. 1, -2, 4. So our answer was 1, -2, 4. Now, am I going to know whether you did it that way or you did RREF? What's the difference? What would you have had to enter in if you wanted to do RREF? Yeah, but what matrix would you have put in? No. -2, 1, 1, 0. You put it all in 1, right? 1, 0, 2, 9, 1, -2, -9, -31. And then you do RREF, and it would have come out 1, 0, 0, 1, 0, 1, 0, -2, and 0, 0, 1, 4. Do you remember that, guys, from yesterday? Okay. So I'm personally a fan of RREF because I hate entering in the matrices, so I'd rather put them all in 1. Okay, we're going to keep going. We're going to do number 8. We're going to do it as matrix multiplication one more time because some weird things are going to happen on some of these, so we need to talk about it. What is the first matrix you're going to put in? 1, not 0, -1, 2, and the next row is, be careful, 1x, 0y, and -1z, and then 3, 2, 1. times, please write it out this way because this is what it's going to ask you on the quiz to write it as a matrix multiplication, I think. 5, -40. And now we're going to call this A and do its inverse times B. And we're going to get X, Y, Z equals some numbers. Okay, I'm actually going to do that on this calculator because I think I can do it faster without that silly. So the first one is a 3 by 3, right? And then the second one is a 3 by 1, 5, -40. So then I go to the home screen, I put the name of A, then I do to the -1 times the name of B. Did yours work? Oh, poop. I put both of them in A, so I rewrote A over the top. Tell me what you got. -1, 0, and 3. Are we agreeing? Okay. All right. So the answer to this is one solution at -1, 0, and 3. I skipped number 7 just for practice. Is that okay? I'm going to skip number 9 as well. Can you do 10 real fast? Talk me through what to write down, though. 2, -1, 1. 4, 3, -7. X, Y, Z. 1, 3, -8. And I think this one does something weird, so I suppose I should try to do it on here. Grr. Okay, I'm on number matrix 7, maybe. 3 by 3. 2, -1. Somebody help me. 2, -1, 1.
4.
Last row.
4, 3,
Okay, does it look right? Okay, then I'm gonna quit and I'm gonna go back in and pick number 9. Oh, darn it. Just forget to go over to edit. Okay, this one's supposed to be a 3 by 1. And anybody? 1, 3, -8? Okay. So if I did this right, mine are in, yeah, that's not looking right. Holy moly. Oh, it's, I don't know. I'm going to try G and I and see what happens. Number 7 to the -1 times, I may have put it in I don't know, it's the right size at least. Is that what you get? Okay. Singular matrix, no inverse matrix exists. Calculated result not found if dependent on a matrix inverse. Okay. So, it means there's no solution, okay? To prove that to you, somebody really speedy is going to read me, do I have 10? Oh, I do, okay. Oh, darn it. Yes.
You press 0 to get it.
Okay, so it's gonna be a 3 by 4, and then I'm gonna do RREF to see what it says. Okay, read it to me if it was all in one.
2, 1,
Hate negatives. Okay. 2, -1, 1.
1. 2, -4, -4, 3, 4, 4, 3, -7,
Okay, mine is in H. Can you help me remember that? So if I go back to the matrix and go to math and up to RREF and H, right? Okay. This is what I got. Do you remember that what that meant yesterday? 0 cannot equal 1, so it meant no solution. Okay? So this, when you did it this way, it said no singular or singular matrix. Rix, no inverse. What that means is no solution. Okay? Now, so there's only 5 homework problems on that tonight. 1 and 19 on page 383, and on page 392, 5, 19, and 26. But you also have to do side A of worksheet 12, because we're going to do side B right now in the 8 minutes that are left. Here we go. Okay. I love this. This is like my favorite thing we do all year. Okay. 12B. I love these because I know the word problems we do in class are so made up, but they really are applicable, and this is fascinating to me, okay? What you do is you're going to solve for all the constraints, and you're going to shade an area. You can only make so many of this, so many of this, so many of this. And you're going to end up with a shaded area. You have to find the corners of all the areas, because any maximums or minimum profit or cost will occur at one of the corner points. Okay. It's not as hard as it sounds, but it's interesting. 1 box of plain cookies requires, okay, Jack and Jill own a small bakery that makes fresh cookies daily. They bake 2 kinds, plain cookies and cookies with icing or frosting, if you're from America. The cookies are sold by the box, and Jack and Jill are confident they can sell all the cookies they make, but there are 3 constraints that limit their production today. I'm gonna jump down here. It says X is the number of boxes of plain cookies they make, and Y is the number of iced cookies, number of boxes, okay? 1 box of plain cookies requires 1.2 pounds of cookie dough, and 1 box of iced cookies requires 0.9 pounds of cookie dough, and they have 72 pounds of cookie dough to work with. So I'm going to use red for cookie dough, and we're going to say 1.2 for every box of plain, which would be X, plus 0.9 for every box of iced, which would be Y, and we have to stay under or equal to 72, less than or equal to. Does that make sense to everybody? Okay. Now we need to graph that. 1.2 and 0.9, 72. Okay. 1.2x plus 0.9y is less than or equal to 72. Is that what we just said? Okay. We're going to use intercepts because it's faster than trying to solve this for y. If I put in a 0 for x, it would just say 0.9 equal x equal, or y, sorry, equals 72. Can somebody do 72 divided by 0.9, please? Okay. If I put a y equals 0 in, it would say 1.2x equals 72. Can somebody do 72 divided by 1.2? So we have over 0 and up 80, and over 60 and up 0. And that is going to be our red line. What happened? I want a line. Okay. I'm just going to use black for now. Okay, that is my line for cookie dough. Okay. Going back, icing. I will do in blue. Okay. Plain cookies require no icing. Oh, this will be easy. 1 box of iced cookies requires 0.4 pounds of icing. So 0.4 what? X or Y? Y has to be less than or equal to 20 pounds, right? Can you divide that real quick? What's Y, 20 divided by 0.4? Y is less than or equal to 50. So if we go over here, Y equals line runs this way. Y is less than or equal to 50 means it has to be below that line. By the way, were we above or below this other line over here? We had to stay below 72 pounds, so it was this side of that line. Don't shade too much yet. Ready? We got one more. Time. Okay, I'm gonna do time in green. 1 box of plain cookies requires 0.10 of an hour, 0.1x, plus 0.15 for the iced, and we have 9 hours. And those are all hours, right? 0.1 hour, 0.15 hour. Okay. 0.1x plus 0.15y less than or equal to 9. Okay, if I put a 0 in for x, what's 9 divided by 0.15? If I put a 0 in for y, 9 divided by 0.1 would be, okay, so over 0 and up 60, or over 90 and up 0. If I draw that line in, and we have to be above or below that area. We have to be below that. So we are talking about below the blue, below the red, and below the green is this area in here. So the corner points, guys, 0, 0. This one is 0.50. This one right here is 10.50. This one right here is 30.40. And this one right here is 60.0. I'm not really confident about that 10.50 one. Is yours crossing at 10.50 or not? No, it's like 15.50, I think. Okay, so if y is 50 in the green equation, so somebody do 90 minus 0.15 times 50. And then divide that by 0.1. What did I do? I was supposed to be putting 50 in for y, wasn't I?
Maybe 15.
With the green.
Instead of 20.
Oh, it's 9, not 90. 9 minus 0.15 times 50, and then divided by 0.1 is 15. So this one is 15.50. Okay. I need those corner points, guys. They were 0, 0, 15.50. Anybody give me the rest of them? 60, 0, 0, 50, 30, 40. Did I have an extra one that I shouldn't have? 1, 2, 3, 4, 5. 1, 2, 3. This one, which one should I not have? 1, 2, 3. Oh, that's 5. Oh my goodness. Okay. Then you have to take the profit. It says the profit is 2 per box of plain plus 3 per box of iced. If they make 0 cookies, what profit are they going to make? Nothing. If they make 15 of this and 50 of these, they will make 30 and 150, $180. If they make only these, 60 times $2, they'll make $120. If they make only these, 3 times 50 would be $180. If they make 30 at $2 plus 40 at $3, yeah, that should be $150. This would be 60 and 120 is 180. So their maximum profit occurs right here. If they make They make $180 if they make either 30 plain and 40 iced or 15 plain and 50 iced.
Hooray. We almost made it.
Yeah.
Is this pencil like rubber or something?